My name is Kaelyn. Let me introduce you to our project. We built a live interactive game where players collect orbs on a map. Here's how it works. Orbs are generated on the map, and when a player walks close enough, here you can see me walking to a blue orb by Doheny Library, they collect it. Their score, which is simply the number of orbs is collected, is displayed right on the right upper side of the game board. To make it more fun, each player is assigned a unique color. You can see here that my color is red, and that is used to identify all my stuff, my marker on the map, and my score icon. Once I reach the orb, you'll see it disappear, and my score will go from 1 to 2. Then I'll hand it off to my teammates so they can show you what's going on behind the scenes.
Hello, this is Aqib. I will be explaining the front end part of our widget. So as we can see, this is our instance lab 5 which is running, and it has this IP 52.8.145.186. So we log in, http, here it is already given, so http slash 52.8.145.186, the IP colon the port number 8080. So this is the widgets dashboard. Usually it asks for the tenant password, but I may not have logged out before, so it does not ask for that, and we are directly logged in. So this is the dashboard. To go to the game, we go to our widgets library. Name of our widget is Orbs Game Map. So here it is, Orb Game Map. So this is our game. This is our map, and we can see here is the scores dashboard. So I will be explaining this JavaScript front-end code, which basically gives the data structures which are used in the map. So self is basically a widget class object that gets initiated on our Thingsboard server. So on init is the initialization function that runs whenever we start an orbs game map. So in it, first it gives an ID, map container ID, which is this map underscore, and this alphanumeric string, basically map.random returns a number, random number from 0 to 1, and toString converts it into an alphanumeric. Alphanumeric is 0 to 9 and 8, the 26 letters. So basically 36, base 36. And then it is always of the form 0.12 AB. So this slices of 0 and point and starts from the actual alphanumeric. So this is assigned the container ID, and then it returns an HTML element self.map.container ID. And then there is a check that leaflet has been loaded, because if the leaflet library is used to create various markers of the orbs and players in our widget, and in case leaflet is loaded in, it's a JavaScript library to create such markers in mapping applications. And in case it is loaded, it defines a global variable L. So in case it is defined, it says leaflet not loaded. After that, we create a map object provided by the leaflet library with l.map with this ID, map container ID, and with these options. World copy jump basically allows us to roll 360-degree across the map, and we won't be stuck. And basically we can roll it continuously in one direction, and it will roll from one position to the other, going into the same direction. Zoom control set to true, and then this is roughly the USC ID, so it is set here, and this is the zoom level. Zoom level basically ensures how many tiles. For example, if zoom level is 1, there are 4 tiles created. If it is 2, there are 16 tiles created. So in that format, there will be 4 is per 16 tiles, so it will be a very great number. And then the layer is added with this URL, OpenStreetMap. S is the subdomain, and Z is the zoom level, X and Y is the latitude and longitude, and S is basically decided with this combination of zoom level and latitude. So this layer gets added, and for every such element that we add to the map, we must give this command add to self.map, else it won't show. Then we create 2 layers, players layer and orbs layer, with layer group function of the leaflet library and add it to the self map. We create these layers group so as to enable us to ensure uh, enable us to do combined delete or update operations on all players or orbs. And then there are various empty objects that are created, like orb markers, which are key value player of orb id and its orb marker, player marker, which is the key value player of player id and marker. Then there is a radius of 10 pixels also defined for all players, and then player state, which is basically key value player for player id, and another object with not object, a kind of list that latitude, longitude, and ts, the latest element of the latest time at which it is updated. Self assigned colors, which is a key value player of player id and its color. Next, uindex, basically a global variable used to get the next color for a new player that enters the game. And then this boolean value did auto fit, which is initially set false and later true when a function of fitting the map runs for the first time. And then we define a control element of leaflet library score div, which on adding runs this function and creates an HTML element of class div and this name scores card, and also adds an inner HTML scores, which will later be used to define, not define, display the scores of various players in descending order. And this gets executed on adding, which is added here right below in this line, add to self.map. And once all these data structures are initiated, this function's map.invalidate size is run so that all the objects fit in the map. So this was the initialization function. And then for resize, on every resize we again run this try block, so that on every resize the elements of the map fit on the map. After that, we have this on data updated function, which runs every time new data is received into the server. So here it stores the context data in the form of rows object and creates an entity data, basically grouping all the data by the entity or from which device it is coming. So what it does is it loops through the rows with each key. Key is basically the uh, entry, the device name, and ds is the entry.data source, and device name is its entity name, basically the name of the device. So it stores, if entity data device name is not present, it creates one, and then it stores its latest updated data, entry.data, entry data length minus one, basically the last value of this entry.data, and one is the actual content of the data, and stores that latest value into that device name's entity data's data key dot name key. After that, it draws player for any player that has latitude or longitude using draw player function, which is later defined after doing some basic parsing and error checking. Then it runs and it updates any new data that is supplied by this context, whether it is the orbs data, scores data, or the debug positions data of the players. So what it does is it loops through all the entries and then stores k as the data key's name, and stores v as its value, and in before that it creates null objects orbs raw, scores raw, debug raw, and then in case the data key name is orbs, it stores orbs raw as the v. In case it is scores, it stores v as scores raw, and in case it is debug positions, it stores debug raw as v. And in case it is orbs raw, so orbs raw won't be null and won't be undefined, so it runs this loop, this block of code. It creates an orbs array, a null array, and in case orbs raw is in the array form, it directly assigns it, or in case it is a string form, it calls the json.parse function of orbs raw and stores it into orbs array. In either case, ultimately, orbs array is an array containing the orbs data, and then it calls, after basic error checking, update orbs, and this function basically updates the orbs data. We will see this function later. Similarly, in case the data.key is scores raw will be non-null, and this block of code will be run, which is similar to orbs raw. It creates a scores object, and in case scores raw is string, it parses it from string to object form, and in case it is object, it directly assigns it and then calls render scores function, which we will see later. And in case data key was debug positions, debug raw will be non-null, and similarly debug will contain the debug raw data in object form, and it will basically contain the latest position of players, and for each key that will be that is the player id, it will loop through using name as the player id or key and call draw player on name, and value.lat value.lon. Value is this p debug name, basically in the key value pair of debug. And then once all this is done, it calls fit to content once, and this function basically fits the map once, and then sets did auto fit true, and next time it is called, if did auto fit is true, which will be true from second time onwards, it will do nothing, it will simply return. The first time it is called, it sets the boundaries using fit bounds function of the map. So this was the function which runs on data updated, which gets run every time data is updated. Now we will see certain helper functions which are called in on data updated. So this function get color for player basically returns the player assigned colors player id if it already exists, and if not, it assigns a new color to the player id and returns that, basically a string that will be used in styling of the icon that we create for the player. And then make person icon, it returns it basically creates a scalable vector graphic class of html element, and returns the icon with this class html person svg, and this size 32 pixels, and icon anchor at this position relative to its this icon, and anchor with this position. This is basically in computer graphics the basically the y-axis goes downward and axis goes right, so 16 is middle and 32 is bottom, so it is middle bottom. And these two functions are called in draw player with this player id and latitude and longitude. So color is assigned get color for player, there's a radius of 10 pixels, the player state is assigned latitude, longitude, and the current time. And then if the marker does not exist, it creates a marker from leaflet library with this icon make person icon, and gets added to players layer, and a pop-up is created with player id, that is when you click it the player id will get displayed, and it gets added to player marker. Similarly, the circle is created and gets added. In case player id already exists, it simply updates the position of marker and radius using set lat lng. This was draw player. Then we see update orbs, which is run in case new orbs data is updated. So what it does, it creates a null object scene. This is basically used to delete objects which are not no longer present in the updated data, and it loops through orbs data with orb id and gives this id, and scene id of is assigned true, and then it assigns the color orb.player player id. In case uh, basically color is assigned, basically this line ensures that in case uh, uh, some player has acquired the orb, the color of that orb is turned to the color of that player, and in case not, then there is a default color. So after that, if the marker does not exist, a circle is created uh, for that orb, and pop-up with its label is created, and it gets added into the orb markers with id as the key. Else if it already exists, the position of that marker or marker gets updated, and style gets updated with the color, because color might have changed in case it has been acquired over the since last on data updated function call. And after that, it uses the scene id data to delete any ID for which scene ID is not true. So this was update orbs function, and then render scores function is uh, used to create a HTML element which contains the name and its corresponding score, current score uh, of every player in descending order. Using this line first, this line host ensures it returns the inner HTML element of the score div element that was created in initiation function, and then it loops through the keys of scores object and maps it to a pair name and score of the player ID, and then sorts it into descending order using this function. This sort function is basically compare swap, which returns descending order if it is b minus a, and then again maps it into a HTML element with name and its score as the string, and then paste it into the inner HTML element of the scores list element. So basically, the scores get displayed in descending order. Then we have fit to content once. This was called in fit data initialization function and on data updated function, but it is run only once, because once it is run, it sets dit auto fit equal to true, and subsequently every time it is called, it simply returns because did auto fit is turned true. Then last, we also have a prunes tail players. This basically function runs every 30 seconds because of set interval prunes tail players. This set interval function uh, runs after every interval of given in the second argument in milliseconds, and this function basically waits for 2 minutes, and in case the latest updated value of uh, any player in player state id.ts is less than 2 minutes than current time, it deletes that player uh, from the player markers array and player radius array, and removes it from the players layer also. So this was the basic JavaScript code which handles the front end of the widget. And now the backend using the Python script will be described by my teammate. Thank you.
Hi, this is Ravi. I'm going to walk you through our EC2 hosted Python service, which powers the real-time orb game on Thingsboard. This is our Thingsboard dashboard, and this is the widget that we created for our game. The blue circle represent active orbs that these players try to collect and compete with scores. The scores are visible over here. Our game runs on this EC2 instance. This is the backend script that we run, the orb manager.py, which updates the locations of players and the number of orbs periodically. This is the orb manager script that we run. These are the functionalities of the script. We first try to log in into Thingsboard dashboard. We then try to get the player IDs of the players active in the game. Then we try to pull the locations, the live locations of the players. These are the live latitude and longitude of the players. And the main focus of our game is location telemetry data. We create a game zone in which we randomly spawn the orbs. Once the orbs are spawned, the players are ready to compete to collect the orbs. And whenever the number of orbs reduces the threshold value, we respawn them. We publish the game state every 2 seconds, and we visualize the game state in the dashboard that I just showed you. We import the JSON library for JSON web token, which would be used as the access token to get into the Thingsboard and send the live telemetry data. We have the time to get the real-time timestamps. We have the random uh, library, which would be utilized to spawn orbs randomly in the game zone. We have the request library to use the HTTP services such as post and get. We also import a few math functions to get the distance between the orb and the player. This is the TB host link where the Thingsboard dashboard is hosted on. We provide the Thingsboard, the tenant username and the password. This is the game token, which is associated with the Game Hub device. This Game Hub device is responsible for the telemetry data transfer. So all of the telemetry data that we get is posted on the Game Hub device, and it is visualized through the widget on our Thingsboard dashboard. These are the current active players, uh, player names in the game currently. If a player is within the 10-meter radius of an orb, the player collects it. The orb color changes from blue to the color of the player, and the orb vanishes. We have a poll period of 2 seconds to avoid any server overloads. This is the spawn area, which mimics the USC DPS zone. The minimum number of orbs is 12, the maximum is 15. This is the active number of orbs, and the orb label is orb. We log it into the Thingsboard dashboard using this function. We use the HTTP service post to get and we send in the tenant user and the tenant password. Uh, this is the tenant user and the tenant password. And we return a token in JSON. We get the device by name. By using the name, we get the IDs of the devices. We send in the token and the name, and we return a JSON. Now, once we have the IDs, we try to get the latest latitude, longitude, and the timestamp for the user. And we use this function, and we use the HTTP GET service to get the latest location points, and the time, and we return a tuple. Now, calculating the distance between a player and orb is not easy as calculating the Euclidean distance. Since we are at the surface of the Earth and the Earth is globe, a globe, we try to measure the distance using the Haversine distance metric. We send in the location of the first position and send in the location of the second position, and then we convert the location into radians, since latitude and longitude are the uh, angles from the center of the Earth. We convert them to radians, and then we calculate the distance between the 2 points and return the distance in meters. Now, whenever we would like to place an orb in the uh, zone, the game zone, we would require to place it randomly. And we use a uniform distribution to get the random locations, and we place the orbs in these randomly located, uh, randomly generated locations. This is the main function. We try to log in and we get the token. We create a empty dictionary which would contain the player name and the corresponding player ID. We iterate over the player names and get the device ID for each player. We also we also generate an empty orb list, which would be used to generate orbs and to check whether the number of orbs is less, the number of active orbs is less than the threshold value. We are iterating over the target orbs and generating a random latitude and longitude for each orb. We get the random latitude and longitude from the lat function that we created. We are initializing the scores for each player. We are creating a function to get the current time in milliseconds, and we create a while loop to run the program until the service stops it. We pull the latest positions for each player, iterating over the player IDs and getting the latest latitude and longitude for each player. We check if the positions are empty or not. We are creating a dictionary to store the summary of the positions. Age S is the time difference between the current time and the timestamp of the position earlier. This is the main logic of the game, and it starts with iterating over the positions and checks if the orb is within the pickup radius for each player. We are calculating the distance between the orb and the player. We have the Haversine metric function to calculate the distance. If the orb is within the pickup radius for the player, we are adding 1 to the score for the player. If the orb is picked up by the player, we are breaking the loop. If the orb is not picked up by the player, we are adding it to the remaining orbs. The remaining orbs helps us to respawn the orbs if the number of orbs is less than the minimum number of orbs. We respawn the orbs if the number of orbs reduces below the threshold value. This is the orb JSON, which we append to the orb list. Since we have done the main logic of the game, we are now publishing the state of the game to the game hub device, which is connected to the Thingsboard dashboard. We debug the positions of the player. This is the payload that we use. The orb is the orbs list. This contains the list of orbs. We have the scores. It is also a list. The debug position is the list position of the players. We are sending this payload to the game hub device. The RR is the response for the game hub device. We are putting the number of orbs and the scores. We are printing the number of orbs and the scores. If the response is not successful, we are printing the error. We are sleeping for a poll period of 2 seconds to avoid overloading the server. And this is the logic of the game, backend logic of the game. Thank you.